Okay, we're going to expand our volume to volume of pyramids, cones, and spheres in this video. Previously, we found the volume of prisms and volumes of cylinders. So now I want you to kind of think about a pyramid at first and how it fits inside of a prism. And here in this picture, I've got a pyramid with the same base and the same height as the prism. So how would the volume of this pyramid compare to the volume of the prism? Well, I hope that we would agree that it's obvious that the volume of the pyramid is going to be less than the volume of the prism. So it's going to be some portion of that volume. So the volume of the prism, remember, is area of the base times height. So the pyramid has to be less than that or some fraction of that. So the question is, what fraction is it? Is it going to be half? Is it less than half? Is it more than half? What portion of the prism does the pyramid take up? It turns out that the pyramid takes up 1/3 of the volume. So this pyramid is 1/3 of the entire volume of the prism that it fits inside of. So that makes it pretty easy to modify the formula. So now we could pretend as if though we were finding the volume of the prism that contains it, and just find 1/3 of that. And that's how we get our formula for the volume of a pyramid. It's just 1/3 of the area of the base times height. And that's what we see here. Here is our formula for the volume of a pyramid, 1/3 of the area of the base times height. So looking at this pyramid in this example, what is the volume of this pyramid? So we want to look at the base, which here is a triangle. So we want to find the area of the base and take that times height, and then we want 1/3 of that. So our volume is going to be 1/3 of the area of the base, and it's a triangle, so that's 1/2 base times height. So 1/2 6 times 8, and then times the height of our pyramid, which is 5 centimeters. So this is going to be how we find the volume of our pyramid. And then doing this calculation, we get 1/3 times 24 times 5, which is 40 cubic centimeters. So pretty easy to find the volume of a pyramid using the formula. Again, it's 1/3 of the area of the base times height. What about cones? Well, we're going to make the same comparison here. If we put a cone inside of a cylinder, because we know how to find the volume of a cylinder, the volume of the cylinder, recall, was pi r squared times height. Now again, the cone is going to be less than that because it fits inside of the cylinder. So what fraction of the cylinder is the cone going to take up? Well, lucky for us, it's the exact same relationship as the pyramid and the prism. The cone actually takes up 1/3 of the volume as well. So it makes it very easy to then derive our formula. 1/3 pi r squared times height is going to be the volume of a cone. So let's look at this example. What's the volume of the cone? And again, we're dealing with circles, so we're going to have to round to the nearest tenth. So our volume is 1/3 of the cylinder, which would be pi r squared times height, which gives us 1/3 times pi times 5 squared times 7, which is 1/3 times 25 times 7 times pi. And as I've said in other videos, I want to do all of this calculation first before I multiply by pi. And that's what I did. I get 58 1/3 pi, which rounded to the nearest tenth is 183.3 cubic millimeters for the volume of this cone. So that gives us pyramids and that gives us cones. What about the sphere? Well, a sphere, the definition is the set of all points in space that are the same distance from a single point. And that gives us our sphere, or our definition of a sphere. So how does the volume of a sphere compare to the volume of a cylinder? Again, it's going to be less than the cylinder. It's going to be some fraction of it. So I'm going to start with my volume of the cylinder, which is pi r squared times height. And as it turns out, the sphere is more volume than the cone was, and it's exactly twice as much volume as the cone. So instead of taking up 1/3 of the space, it's going to actually fill up 2/3 of the space of the cylinder. So that gives us our formula, 2/3 pi r squared times height. Now the problem here is we don't have a height of a sphere. A sphere doesn't have height. It just has radius. That's all it has, because it's all of the points that are the same distance from a single point. So a sphere really doesn't have height. All it has is radius. So if you think about the height of a sphere, what is that height going to be? Well, it's just going to be twice the radius. It's going to be the diameter. So it's twice the radius. So I need to replace the height with twice the radius. So our formula becomes 2/3 pi r squared times 2r, which would be the height of our sphere, so to speak. Now this is kind of jumbled here. I've got numbers and I've got r's all over the place. I'm actually going to simplify this formula a little bit. So I'll have 2/3 times 2 times pi times r squared times r, and I just rearrange the terms there, and then I can simplify this even further to 2/3 times 2 is 4/3 times pi, and then r squared times r is r to the third power, or r cubed. And this is actually the formula for the volume of a sphere, and that's how it's derived. It's derived from the volume of a cylinder, and we have to modify it because spheres don't have heights. So our volume of a sphere is 4/3 pi r cubed, and that's what we'll see right here. And that's where that formula comes from. It's kind of an odd formula, 4/3 pi r cubed. So what is the volume of this sphere? We're going to use 4/3 pi r cubed, and remember to take to the third power, not to the second power like we have in all of our other circular shapes. We get 4/3 times pi times 8 cubed, and 8 cubed is 512. So we have 4/3 times 512, which gives us 682 2/3 pi. And again, I wait till the very end to do my calculation with pi. I multiply that by pi and I round to the nearest tenth. It gives me a total volume of 2,144.7 cubic inches. And there you have it. Those are the volume of our pyramids, cones, and spheres. We derive those from the volumes we already know, prisms and cylinders.